Hi, welcome to the session on data structures using Python. In today's session, we will be working on stacks using lists in Python. In order to access this, you do need to have a Hack with a one-to-one account. And within Hack with a one-to-one account, under the structure, data structures using Python self-learning, we are maintaining all the labs here. So I'll quickly give you view of the sample lab, and then I'll let you know how you can quickly get access to all the labs which we will be covering during this program. So this is the lab over which we will be implementing our practical applications. Today's objectives are stack, so we will be working on stacks today. Now, in order to quickly get access to it, you can quickly go to hackveda.in. Over hackveda.in, under Python programming section, we do have data structures using Python self-learning. Okay, I'm sharing the link with both of you on chat. You have to quickly click on this link. Once you come to data structures using Python self-learning, there is a get started section. You can quickly register on the get started section. As of now, we have added 2 labs here, introduction to Python and stacks using lists in Python. More labs will be added onto it. So what you do need to do is you just have to click on get started free, and here you will be able to access the lab. Okay, so you will be redirected to Hackveda one-to-one registrations under the event programming languages. I'm sharing the link with you over chat. Just go here and click on it. Once you guys will click on it, you have to provide your name, email, mobile number, and register now. Once you register, you're going to get access to Hackveda one-to-one. Okay, so under Hackveda one-to-one, you're going to get a course named as Data Structures using Python Self-Learning. This is the course module. You have to select Data Structures using Python Self-Learning module. And under this module, you will be having 2 labs as of now. So here, the video is an introductory video, and you can quickly click to start lab to access the content. So once you click to start lab, your lab is going to open. And here is your lab, which we will be working today. Okay, so guys, once you are done accessing the lab, please let me know. Arush and Jerry, is it clear? Where will you be able to access it?
It's showing some error. It's saying that your connection is not private.
Sorry?
It's saying that your connection is not private.
You can click on continue using the website, not a problem. In case if you get any thing like save connection, there are certain HTTPS issues. We are configuring that. So for now, you can quickly click on proceed to the website. Go to advanced option and click on proceed to the website at the very bottom. So just make an account, all 3 of you, and you all need to quickly access your content from here. So once you will be able to access your content from here, you will be able to get your relevant module, and you will be able to access the lab properly. So to access the labs properly, you do need to have a one-to-one account. Okay. Now we'll begin with our topics of the day. Let us just quickly get started with the course. So I have initialized the course. So today we will be covering stack using lists in Python. So using lists in Python, this is a difficulty beginner level, and approximate duration for the lab, if people do it self, it is 20 minutes, but it might take a few more time for us because we will be discussing and doing a lot of things. So our objective of the day to cover here is using lists as stacks. That is what we are going to implement. Now, what is how we are going to use it? So we are going to write our content here. So you have to log into the Linux shell below. Username is my username, password is my password. So you can quickly go to your shell here. Just type in my username, and you can quickly type in my password. Once you're here in the shell, you can clear it and make a directory with your name. Let's say I'm going to make a directory with the name Devanshu. I'll go to my Devanshu directory, and I'm going to write all my codes here. You can access your own directory. Okay. I believe you have made your directories previously. In case if you have not made it, you can quickly make your directories by the command mkdir and your name or something. Okay, you can quickly use your name to make a directory. Now, once you guys are done making the directory, you have to get into your directory so that you can maintain all your source code, and I will also be able to evaluate your source codes once we are done. Getting to the next step, to get started with what is a stack. So guys, as you can see on the left hand side on the data visualizer, we are currently on the stack module. So you can quickly reach out to the stack module. In the stack module, you have a sample random stack made up over here. Okay. So let us just quickly go through with the definition of stack. So a stack is a last in, first out data structure. The last element that is placed in a stack is the first element that can be removed. So you can see that in a stack, we try to insert data into this format. Okay. So this is going to be the first element, then this is going to be the second element pushed, this is going to be the third element pushed, and this is going to be the fourth element pushed. So as per the definition, if you're going to remove the last element, so this element is going to be popped off. So elements can be inserted and deleted only from one side of the list. And this side of the list is known as the top. Okay. We call this section as the top of the stack. I believe this is clear to all of you. So you do have a samples stack on the left hand side. You all can quickly create a random stack as well. You can go to stack, you can quickly go to create, and you can create a random stack so that you can quickly have an idea how stack looks like. And here over the stack, we do have a tail. So this is the tail element of our stack. Oh, sorry, head element, or you can call it as a top of the element. And all the push and pop operations will be done at the top level only. Now, I believe you all are clear with the definition of stack. What is a stack? Stack is a last in, first out data structure. Clear? Arush, Jaideep, and Arush, Palak?
Yeah.
Yes, sir.
Great. Let's go to the next step. Now what is the stack definition? Let's have a quick look. So the insertion of an element into stack is called a push operation. So let's say in case if you want to insert any new element, so I'm going here and I'm adding 53 on this list. So once I do that, a new vertex will be created and head will be replaced. Okay. I'll just keep the animations a little slow so that it is observable to all of you. Now you can see that what has happened here. The insertion of an element into stack is called the push operation. So once I have performed the push operation, 53 has been inserted at the top of the stack and the head and the top is changed. Can you see that? Deletion of an element from the stack is called the pop operation. So how do we perform a pop operation? Let's say if we go here, we click on pop. So now the head of the list will be identified, which is the top, and then it is going to be removed and its next pointer will be replaced with the next element and it will become the top element. Can you quickly observe? Now you can see that this operation is known as the pop operation. And now what exactly is happening? All this pop and push operations are happening on one side only. In stack, the last element in a list is tracked with a pointer called the top pointer. So I have already told you, we do have a top pointer in a stack and our elements are actually tracked with this top pointer. Okay. Now coming to some of the basics of algorithmic analysis of stack, popping an element from a stack will take a big O of 1 time complexity. And what does this mean? So let's say if I quickly go to the pop operation, I'll quickly show you what exactly happens over here once we pop. So we go to the temporary head. This is big O of 1 operation. This is big O of 1 operation, and deleting the record is big O of 1 operation. So we have 3 operations here. Let's say computer is going to take one operation, because assignments, whenever you assign a value, that is also known as big O of 1 under RAM model of algorithmic analysis. Okay. Similarly, once you are in the second step, again, you are assigning an operation. So that is again a big O of one operation. And once you are deleting it, that is also a big O of one operation. So adding, subtraction, multiplication, division, assignment, deletion, removing, or indexing, all these operations are big O of one. So what exactly will happen here? If I quickly go here and if I add all the three, big O of 1 plus big O of 1 plus big O of 1, it eventually adds up to big O of 1. Okay. And that is generally known as the constant time, which means whatever is the size of the stack, whenever you are going to perform a pop operation, it is always going to be done in a constant time. In our next lab, I'm going to show you it in a very nice animated way about how each and every algorithmic analysis is being calculated with every operation. In the next lab, you're going to learn about it. So for now, what we are doing is we are dealing with the stack operations only. Okay. Now, just give me a confirmation if this is clear, that all these three operations are big O of 1 and collectively they are called as big O of 1, which is a constant time. And constant time means whatever is the size of the stack, always it is going to take one step to remove the element. Now, if I actually create a random list, okay, if I go here and if I create a random list of fixed size, and let's say if I add up 20 elements here onto the list, okay, onto the pop, let's say 20 is going to increase the size, and I'll just add up 5. Okay, let's say. So I've got 5 elements over here. I have added them into the list. Now, whatever is the size of this stack, if I perform a pop operation, it is going to again execute in the constant time, because I have got the head, big O of 1, got the next, big O of 1, deleted that element, big O of 1, and hence the outcome is a big O of 1 fixed time complexity. I believe this is clear. Palak, Jaideep, and Arush.
Yes, sir.
So this big O notation is nothing but it is actually known as RAM model, RAM, random access memory model of algorithmic analysis, algo analysis. Okay. So we will be working out on it. We will be understanding about each and every algorithm. And in the next lab, I'm going to show you certain techniques with which you can quickly automatically calculate these complexities for any of your codes you're writing. Okay. And then with respect to memory analysis, you will always be able to write the optimized code, and you will always be able to understand where is the gap where you can actually fulfill the gap and improve the time complexity of the program, whatever you are writing in. I believe this is clear to all three of you. Now, going on to the next step, let's proceed to the next step. Once I click here, over continue, one more thing. Now let's see, here we are saying popping the last element in a stack will take big O of n operation. Okay? What does this mean? Now, suppose if we are doing a pop operation, okay, and if you want to pop this last element out, okay, so suppose you do have size n, okay, you have n number of elements within the list, okay. So what exactly will happen all the time, whenever you are going to pop the lastmost item, it will naturally go to the lastmost element again and again, which means it's going to pop this one first, followed by second operation, followed by the third pop, and then again it will go to the last nth element. So in this case, this popping from the last element will become big O of n operation. Okay. I believe this is also clear. If you have to pop the last element in the stack, it will take big O of n time complexity. Now, going to the next section, we'll quickly see an example stack over here. So example stack you have already seen. We do have a top. We do have n number of elements here onto the stack. We'll quickly go and click on continue and we'll see the next step. Now here, so we have to make use of stack, but in Python, stacks are not available by default. What do we have to do? We need to make use of list in order to make them appear as stack and perform the stack operations. Okay. So we are going to make a combination of both the linked list and the stack in order to understand how we can make the most out of it. Okay. Now, the list method make it very easy to use a list as a stack, where the last element added is the first element retrieved, which is again last in, first out. So if you can quickly observe here with respect to your stack, which is the lastmost element, 97 is the lastmost element, and once we are going to pop it out, 97 is going to be the lastmost element. Okay, suppose if I just clear it, so what I'll do is, let me just quickly add one more element. Once I'm going to push an element onto a stack, let's say 53. So the last element pushed onto this stack would be 53. This will actually take big O of 1 time complexity when you perform an insertion operation again, because you can quickly observe big O of 1. Okay, adding a head, this is an assignment operation, big O of 1. This is also big O of 1 operation. So collectively, when you add all these three, you're going to get big O of 1 in a constant time. So this means the last element added is the first element retrieved. So now, once we want to retrieve the element out of this, I'm going to pop it. So again, I'm going to identify the top. I'm going to identify the head. I'm going to replace that value, and I'm going to delete that temporary and change the top. Okay. So now what do we have is to add an item to the top of the stack, use the append method. So in Python, what do we need to do? We need to make use of append method to append an element to the list. And as you already know, once we append an element in the list, what exactly happens? I'll quickly give you an explanation. So we go here onto the linked list, and I'm going to create a linked list of the similar fashion. Okay. Suppose I'm going to define a user list of 5 elements. Okay. Let's say 1, 2, 3. I'm going to create a list of 1, 2, 3. Now, what do we have to do is to add an item to the top of stack. Consider this list should act as a, consider this will act as a stack. And here, your top pointer is going to be this. Okay. This is going to be your top. Okay. This is the last position. So now what is going to be done? Once you're going to append an element, so the top is going to be replaced with the new element coming into the stack. Okay, so you can consider this as a stack in a horizontal fashion. Okay, now, so we are going to insert, and here the operation will be an append operation. So we are going to add at the end of the list. Okay, so let's say if I add up 4, so what is going to happen? A new vertex is going to be created. Temporary value is going to be changed and saved onto the pointer, and then the temporary value will be changed. So guys, can you quickly tell me the time complexity of this append operation? I'll go one by one. First, Arush बताएंगे. Arush, what is the time complexity of this one? When you are creating a new vertex? Am I audible?
Yeah.
Palak, you tell me, what is the time complexity of this operation when you are creating a new vertex?
Big O of 1.
Right. Second one, when you are assigning temporary to tail.next.
Same. Big O of 1. And
Big
third
O
also.
again, big O of 1. So collectively, this is going to be a constant big O of 1 always, whenever you are going to add up to the end. Okay. Whenever you are going to append an operation. Now, similarly, to retrieve an item from top of the stack, use the pop without an explicit index, which means we don't need to define an index, and we can quickly perform the remove step or the pop step. Okay. So let's say this is going to be my remove position, and I'm going to remove an element from the tail. Okay. It says remove an element at the tail when you're using list as a stack is going to be a big O of n operation. Okay. So what is this? It's going to happen. Now you can quickly observe. We are going from first element to the second element to the third element and finally to the fourth element. Now here, if you calculate the time complexities of the process happening, the first statement vertex previous equal to head is big O of 1. Second head dot next is big O of 1. But once you're going into this loop, temporary dot next is not equal to null, which means you're going to loop through all the iterations. So if you have n number of items in the list, this becomes big O of n. Okay, I'll quickly type it over here. Let's say this operation we'll start from here. This operation, big O of 1. Second operation, big O of 1. Third operation, big O of n. Because suppose your stack has n number of elements or your list has n number of elements, so it is going to loop through each one, right from the first to second to third and to the last one, and then it's going to remove that. Then again, once you come to this step, this is going to be big O of 1 operation, deletion, big O of 1 operation, and assignment to the tail, big O of 1 operation. Okay. So now once you're going to add this, okay, I'll just add it over here. Now suppose you're going to add all these. So again, your big O of 1 plus big O of 1 plus big O of n plus big O of n plus dot dot, whatever it is, however, how many are available. So finally it becomes big O of n time complexity. Hence what we say, when you are going to remove an element from the stack, it is going to be big O of n when it comes to list pop removal. Okay, अगर आप stack को as a list use कर रहे हो, list को as a stack use कर रहे हो, so the removal operation will always be big O of n. Okay, like that. So that is very, very important to understand. Now coming to the next point, let's quickly proceed further. I hope this is clear till here. Just give me a confirmation, guys, if this is clear.
Yes, sir.
Great. Going to the next point. Now, as you can see, we have not specified any explicit index to pop the element out. Let's get to the next one. Now, once we're going to the next step, you're going to create a list in DS Viz. Okay. So you have to go to the menu bar, create a stack, which we have already done. But for the sake of completeness of this, let us just quickly observe what we'll do. We'll quickly go to create. We're going to go to the list. We're going to go for a user defined list. I have to type in 1, and then I have to make something like, I have to add 2, a push operation. Then I have to perform push 3, 1, 2, 3, I'm going to push. I'm going to perform push 4. Okay. And finally, I'm going to get a stack somewhat like this, 1, 2, 3, 4. This is what we need to make. We need to make a stack which should look like this. So how can we do that here? We will quickly go to the stack structure. We'll go to user defined list. We're going to make 1 entered here. So now this becomes your first element pushed onto the stack. Then we are going to push in 2, 3, and 4. So let's say you have pushed 2, created a vertex, changed the head, and assigned the temporary value to the head. So we got 2 pushed. In the similar fashion, we are going to insert 3 and 4. Okay, and we're going to have 4 also. Now, so now you can see that on the right hand side, you do have a stack which has value 1, 2, 3, 4. And on the left hand side also, you do have this 1, 2, 3, 4. A stack is available, and 4 is at the top of the stack as of now. Just give me a confirmation if you guys are done till here. Let's click on continue. Now here what we are going to do. Now you're going to create a stack using list in your Python interface. Okay. So what we'll do, let's just quickly run Python, and you guys will come into the shell of this Python directory. What do we have to do here? Let's say we are going to create a stack, and to create the stack here, you're going to make a list here. Let's say I'm going to create a list something like this. Stack is equal to 1, 2. You can follow the instructions given to you. And then what am I going to do? I'm going to append the operation. So we can quickly perform append. Then again, you can use stack.append. You can add in an element 4. And finally, what you have to do, you have to print the value of the stack out. So here you do have the stack element represented over here. Here is the stack in the virtual format. In Python, we don't have a stack data structure, but what exactly we have done here, we have made an implementation of stack using list data structures. Okay. So this create a stack using list part is done. Kindly give me a confirmation if you guys are clear till here.
Yes.
Let's quickly go to the next step. Now in the next step, what we are going to do, you're going to perform 2 pop operations, and then again, you're going to show me the value what you are going, what you are left with. Okay. So suppose we'll quickly go here for the visualization. If I pop in one element, so once we pop, we are going to get the fourth element removed. Okay. So the layout has been done. If I again perform a pop operation, again you can see element from the head would have been removed. It represents big O of one time complexity, but in Python it is big O of n. Is that clear? Because you are implementing that with list. Okay. Now, so once we are done with that, we are going to quickly perform this operation here. Let us just perform stack dot pop. Once you're going to perform pop operation, you can see that 4 has been popped out of the list. And then again, once you perform pop again, you can see 3 has been popped out of the list. So once you perform the pop operation, these values are fetched out and are returned back. Now, if you want to print the content of the stack, we'll quickly put stack and we can see that we have got 1 and 2 available. So 1 and 2 on the DSViz is giving you a stack structure, because stack helps you in depth first search, and that is kind of a representation we are having here. And here on the shell, you have a list implementation of stack. Now, let's proceed to the next step. We'll go here. I believe you all are done till here. Are you guys done with the fundamentals of stack? So
yes, sir.
Stacks are generally used for the push operation and the pop operation. And you have seen the algorithmic time complexity of the push and pop operations also. In general, the push and pop operation should be big O of 1 with respect to the implementation in DSViz. But in Python programming language, since you make use of list data structure to use it as a stack, so in that case, when you are removing an element from the end of the list, that is a big O of n time complexity operation. Okay. Now, so we got that understanding done. Now we are going to get started with some practical algorithms. Where can we use stacks? So stacks are mostly used in depth first search problems and algorithms, and we will be working a lot on those kind of problems. But before that, I want to give you something, one algorithm which is going to give you some relevance. So I believe you all have seen, you all do programming, और आप लोगों ने देखा होगा कि हम जैसे Java programming लिखते हैं, तो we make use of scope, we make use of brackets. Okay. ऐसा ही हम एक यहाँ पे एक program बनाने वाले हैं. There is a problems on stack here. What do we need to do is we need to use a stack to check if a string has balanced usage of parentheses. This is our problem statement. Okay. So balance usage means in case if you have an opening braces and if you have a closing braces. So this is known as a balance. So we are going to write a program and we are going to quickly check back, are we able to calculate the parentheses and if the parentheses are balanced or not. That is what we are going to implement. And here is an example of unbalanced parentheses, because you can see that there might be some n number of closing brackets or opening brackets which might not be equivalent with their other half. Okay. Is the problem clear? What do we have to implement? We have to use a stack to check if a string has balanced usage of parentheses. Kindly confirm if the problem is clear to you guys.
Yes.
So we are going to write a program. Given a string of parentheses, we have to identify whether that string is a balanced string or not. That is the objective. Going to the next step on this, let us just quickly have a solution approach. How we can quickly solve this kind of problem out. Okay. So what we will be doing in, let me just quickly plot a stack for you. Okay. I'm going to make a stack and we'll see some of the operations. Okay. Let's say, okay, I'll just work out on it a little. I was trying to implement this, but abhi khair pura nahi bana pa raha hu main. So once that will be implemented, we'll see. But anyways, I'll put numbers here as of now. Okay. So let's see. So I'll just initialize a few operations. Let's say a random fixed. Sorry, we'll do something like let's say 5, 4, 3, 2, 1, just to understand the approach. Okay, so suppose you have this element over here and you have a balanced and non-balanced kind of structure here. Okay, तो दो हम बनाएंगे, एक हमारे पास लेफ्ट हैंड साइड में बैलेंस्ड होगी और एक नॉन बैलेंस्ड होगा. ओके, so दोनों को देखते हैं कि what should be our approach. So on one side we do have a balanced and on second side we'll keep unbalanced. Okay, now here, so first operation पे मान लो आप कि जैसे हमारे पास बैलेंस केस में एक ये है, ठीक है, सॉरी उल्टा बनाते हैं, विल कीप इट फ्रॉम हियर. सो जैसे अगर हमने फर्स्ट को इंसर्ट किया तो दिस इज गोइंग टू बी इंसर्टेड, सेकंड को इंसर्ट किया दिस इज गोइंग टू बी इंसर्टेड, लेट्स से, फिर इसको इंसर्ट किया, ठीक है, देन फोर्थ मान लो ये है हमारी, ठीक है. 5 में तो किसी भी फॉर्मेट पे बैलेंस हो ही नहीं सकता, ठीक है. So मान लो आपके पास 6 elements होते हैं, we'll just push one more here. 1, 2, 3, 4, 5 and we'll have one more, 6. Okay, let's just push one more. वैसे मैंने max 5 की लिमिट रखी है इसमें, otherwise you can take up with 4 also. Okay, we'll just insert one more 6. हाँ ठीक है, यहाँ पे ना max का रखिए, एक पॉप कर देते हैं, चलो. I'll just pop the fifth one. ठीक है, 4 होंगे आपके पास. ओके, सो मैं नीचे वाला ये है इरेज कर देता हूँ. नाउ लेट्स सी. सो चलो एक बार दोबारा से ही देख लेंगे इसको हम, ठीक है, यहीं से ड्रैग एंड ड्रॉप करके देख लेंगे. चलो, नाउ व्हाट वी आर गोइंग टू डू, आप देखो. सो वी आर गोइंग टू हैव अ बैलेंस्ड वन एंड वी आर गोइंग टू हैव एन इम्बैलेंस्ड वन. सो व्हाट इज गोइंग टू बी द सॉल्यूशन अप्रोच? सो टू सॉल्व दिस काइंड ऑफ प्रॉब्लम आउट, we are going to loop through the given string. Whatever string is given to us, we are going to loop through that string. Okay, suppose we have this string. Okay, ये है हमारे पास, दो लिख लेते हैं, चलो यहाँ पे एक सैंपल, ठीक है. जैसे एक ये है, ठीक है, we have something like that. एक ठीक है, suppose you have some 4 parentheses over here, somewhat like that. Similarly, एक दूसरा हमारे पास है and this could be something, any unbalanced one. Okay, let's say, so ये दो cases हैं आपके पास. Let's call it as, first one is going to be balanced, we call it as B for balanced. Okay, and one I have is an unbalanced one. Let's just keep it unbalanced. Okay, now guys, let's have a look. So what are we going to do now in order to perform the solution approach? So you're going to loop through the given string. If we encounter an opening parenthesis, we push it onto our stack. Okay, and if we encounter a closing parenthesis, we pop from our stack. Okay, so if we encounter a closing parenthesis and there is nothing to pop from our stack, that means the string is unbalanced. यानी आप क्या कर रहे हो कि जब भी आपके पास एक ओपनिंग पैरेंथेसिस आ रहा है, आप उसे पुश कर रहे हो स्टैक के अंदर, और जैसे कोई क्लोजिंग पैरेंथेसिस आ रहा है आप उसको एक्सट्रैक्ट कर रहे हो. ठीक है, तो अगर लास्ट में आपके पास कोई ओपनिंग पैरेंथेसिस है, ठीक है, और आपका स्टैक पूरा का पूरा पॉप हो चुका है, तो दैट मीन्स इट इज गोइंग टू बी एन अनबैलेंस्ड स्ट्रिंग. ठीक है, सिमिलरली that is one way of checking it. Second, if we have completed looping through of a string and our stack is not empty, यानी हम अपनी पूरी की पूरी स्ट्रिंग को हम ट्रेवर्स कर चुके हैं वन बाय वन, ठीक है, एक एक पैरेंथेसिस को हम लेकर के चेक कर चुके हैं, एंड एट द एंड our stack is not empty and we are done with processing all the iterations, which means checking all the parameters at every index of the string. So then also we get to know that the string is an unbalanced string. Okay, so how we are going to perform it, let's have a quick look. So what exactly is going to be done? So we say, let's say we are going to create an iterator I. Okay, let's say we are going to create an iterator I, and let's say we'll start from index number 0. So this is going to be the index number 0. Then what we have to do is we have to loop through it. Okay, you have to loop through it, and till when you're going to loop? Until the size of this. Okay, so you're going to length, and you're going to take the size of that string, and you're going to loop until your value of I is length of that string, because we need to calculate each and every one. We need to take up each and every parenthesis, and we need to put it onto the stack, and then we need to pluck it out if we get its other part. So now what we have done, let's say we encountered the first one. Okay, so let's say if you encountered the first one, I'll take a green step here. Okay, so I have got the first one encountered. I have inserted onto the stack. ठीक है, stack में insert कर दिया. यहाँ पे हमारे पास first element पे एक opening parenthesis store हो गया. ठीक है, second हमने iterate किया. We have gone to the while loop and we were iterating. ठीक है, to the second one. Second भी हमें मिला, opening parenthesis था, हमने उसे stack में push कर दिया. ठीक है, then we have gone to the third one. जैसे हम third पे आए, हमने देखा कि third अगर closing parenthesis है, तो we are going to perform a pop operation from the stack. So once we are performing a pop operation out of the stack, so this becomes empty and we are done with this one. यहाँ तक close हो गया. Now we have gone to the fourth step. जब हम fourth step पे गए, हमने मिला closing parenthesis. हमने closing parenthesis मिला तो again हमने pop operation perform किया. ठीक है, अब ये होने के बाद क्या हो गया? Our stack became empty. Okay, and our length of string has been iterated. ठीक है, तो इसका मतलब क्या है कि ये वाला जो हुआ ये बैलेंस्ड स्ट्रिंग का एग्जांपल था, कि दिस स्ट्रिंग वाज अ बैलेंस्ड स्ट्रिंग व्हिच हैज इक्विवेलेंट नंबर ऑफ पैरेंथेसिस. ओके, सिमिलरली अब अगर हम देखते हैं दूसरा अप्रोच. ठीक है, सेकंड को हमने लूप ओवर किया. सेकंड को अगर आप लूप ओवर कर रहे हो, व्हाट इज गोइंग टू हैपन? आपको फर्स्ट एलिमेंट मिला, दिस वाज अ क्लोजिंग ब्रेसेस, यू हैव डन अ पॉप. ठीक है, आपने पॉप ऑपरेशन परफॉर्म किया. पॉप ऑपरेशन कर ही नहीं सकते क्योंकि एम्प्टी है. ठीक है, तो एम्प्टी है तो नेचुरली बोल दिया अनबैलेंस्ड. ठीक है, स्टार्ट हो गया अनबैलेंस से कि ठीक है, हमने एक फ्लैग भी बना लिया. मान लो एक इज बैलेंस्ड इक्वल टू फॉल्स. ओके, एक हमारे पास फ्लैग है, मान लो ट्रू एंड फॉल्स की वैल्यू होगी इसमें, इज बैलेंस ट्रू एंड फॉल्स. तो अगर पहला ही हमको क्लोजिंग पैरेंथेसिस मिल गया तो हमने नेचुरली उससे स्टार्टिंग से बोल दिया कि ये अनबैलेंस्ड है, और हमने अनबैलेंस्ड को ट्रू कर दिया. ठीक है, नाउ गोइंग टू द नेक्स्ट स्टेप. सेकंड स्टेप पे हम चलते हैं. व्हेन यू गो टू द सेकंड स्टेप, अगेन यू हैव गॉट अ क्लोजिंग पैरेंथेसिस. सो अगेन यू ट्राइड टू पॉप. वंस यू ट्राइड टू पॉप, stack was not empty, stack was empty. So again you got it false, that the string is unbalanced. Then you got on to the third one, you pushed it onto the stack. Okay, and once you pushed it onto the stack, you have gone to the next step. Next step में मिला आपको closing parenthesis. Closing parenthesis मिला तो again you have performed a pop operation. Okay, so जब आपने pop operation perform किया तो अभी आपके पास string तो over हो गई, लेकिन आपके पास is balanced वाला जो flag था, that is always showing false, because we do have two existing closing parenthesis which does not have an opening parenthesis. So that is how we can quickly check if an element or a string of parenthesis is a balanced string or an unbalanced string. Okay, guys, give me a confirmation if the approach is clear to you. Solution approach समझ में आया, how it is working? So if we have a stack here, we can quickly solve this problem out of calculating the equivalent parenthesis. Just let me know if this is clear to you.
Yes, sir.
Clear? Great. Now, Now what am I going to do? We are going to have a quick, we'll just go to the next step where you do have a solution approach of what we have discussed over here. So with the solution approach, what we can do now, we can quickly get started with creation of an empty stack, let's say, okay? Because at the starting, stack is going to be empty. Then you're going to create a flag is balanced is equal to true. Let's say by default, we'll say that the stack is true. But in case if we get a closing parenthesis, we are going to convert this value to false. We are taking an iterator. This iterator is something which will help us in calculation of the strings. Okay? Index of 0 se leke index of length -1 tak, we are going to traverse the string parenthesis. So that is why we are initializing it. So what we can do is, let us just quickly, I'm going to clear this operation and we are going to perform this over here. Okay. So guys, let's just have an exit from this shell, and under your directory, open Nano editor and just make your program solution1.py. Okay. Go to your directory and make a new program solution1.py. Okay. So if you don't have Nano, let me just quickly install it. Sudo apt install Nano. My username, you don't need to do it. I'm just doing it. You will get that. Okay, I'm installing that on the shell for everyone. So by the time it installs, let's have a quick look of what is going to happen. Followed by this. Now we are going to perform a while loop. First, we are going to check if we do have an element existing in the string as well as our is balance is true. जब तक ये true रहेगा, तब तक हम perform करते रहेंगे अपने steps को. Perform क्या करते जाएंगे? We are going to read the character from the string or the parenthesis from the string, and we are going to save it into a variable, let's say parenthesis. We're going to check if the parenthesis is an opening braces. We are going to push it onto the stack. If the parenthesis is a closing bracket, we are going to check if there is an element in the stack, we are going to pop it. Otherwise, we are going to set it as false if we don't have any element. And then we are going to increment the value of the iterator by 1 so that we can read the second character. Okay. Now, let me do one thing. Sudo apt update. Let me just update the shell. I would have restarted it. That's why the information would have gone, but I'm just connecting it in a moment. So you're going to iterate over the next character. You're going to match it. Okay. Finally, if you do have any element left in the stack, any opening parenthesis left in the stack, and all the characters of your parenthesis string has been traversed, so naturally it becomes an unbalanced string. Okay, so we are going to save false into is balanced, and we are going to return that content out. So we are going to write this approach, and with this we are going to quickly calculate whether the string which we do have is balanced or unbalanced. Okay. Also, in this workshop, somehow in case if you are doing this hands-on workshop alone, you can quickly go to the next step also. Apart from the solution approach, we do have a practical implementation of the approach here. On the last step, I'll show you that. So here we do have a complete implementation of how to the solution on balanced parenthesis problem. So we have defined the method here known as is balanced, which is going to test two conditions. One, we do have a set of balanced parentheses. Okay, I'm opening that. By the time our server is getting installed, and before that we write the code to the solution on balanced parenthesis problem. So we have defined the method here known as is balanced, which is going to test two conditions. One, we do have a set of balanced parentheses, and second, we do have a set of unbalanced parentheses. So we are going to quickly run this program and show you how the approach should work like. So when we define this method is balanced, we are going to run this program. Now we'll quickly get involved into the statement, how we are going to process it. So first, we are going to call this method is balanced. Is balance has taken a set of string which has some n number of strings available, which might be balanced or imbalanced. So we are going to read that string. Now once we have read that string, we are going to perform isBalanced method. We are going to execute it. So now in this isBalanced method, the first thing which you have to do is you have to initialize a list S. This list S is going to be empty. You can also call it as a stack, as you have learned above. Now out of this stack, this is an empty stack. You're going to initialize one variable known as isBalanced, which is going to be our output, and let's call it as true. Initially we consider, let's say the string is going to be balanced. Now we're going to initialize a variable I. This I variable will help you iterate over each parenthesis within the string. So starting from index 0 of the string, we are initializing I equal to 0, followed by we're going to write a while loop with which we can iterate with each and every parenthesis within the string, as well as we are going to run this loop till the iterator is less than the length of the string and the isBalanced flag is true. So we're going to quickly get into this while loop. These are the two conditions which we are going to check. Now the first condition is iterator should be less than length of the string, which is the length of the parameters, and the second is the flag, which is isBalanced. So in case if isBalanced is equal to false, then we are going to come out of this while loop, or else if the length, if the iterator is less than the length of the string and the string is true, isBalanced is equal to true, we are going to come out of the loop. Now let's fall into this loop. We have checked the first condition. Let's say we have gone to first input variable. Now within that input variable, we do have a parenthesis. We check whether that iterator is less than the length of the string. Yes, we got that condition satisfied. Then we have checked whether isBalanced is equal to true. Yes, for the very first time isBalanced was true, so we will get into this while loop. Now once we get into this while loop, out of that string we are going to read its first character, and we are going to read that first parenthesis into a variable known as parent, P-A-R-E-N. Now the value has been stored. Now we are going to check with if this variable parent is equal to an opening parenthesis or a closing parenthesis. So in case if it is an opening parenthesis, let's say, so we are going to read the parenthesis and we are going to append it onto a stack. Okay, so you can follow the append operation and push it onto the stack, followed by, in case if your element is an opening braces, what we are going to do, we are going to come out of this condition. We are going to increment the iterator by 1, which means we'll again go to the second character of the string and we are going to read that parenthesis and we are going to check what is it. So we have fetched out the second parenthesis. In this case, the length is less than the length of the string. So guys, I believe you were able to observe that, the solution approach, and now we are going to quickly implement that. Okay. So let me just install sudo apt install Nano. Just give me a quick confirmation if you're clear with what is the problem and how you're going to use stack in order to solve it out. Am I audible? Hello, is my voice audible to you all?
Yeah.
So is that clear? The approach solution? Hello?
It's not a bit clear, but I need to go through it again.
Okay, where it is not clear?
I didn't got what we are trying to do in this part.
In which part? Are you clear with the problem?
Yeah, the problem statement itself. I mean, I got the balanced and not balanced, but
Sorry, I cannot understand what you're saying.
Understand what needs to be done.
You are clear with the problem or you are not clear with the solution? What is it? Exactly what is the problem?
I'm not clear with the solution approach.
You're clear with the problem, right?
Yeah.
And Arush and Jaideep,
Yes, sir, clear.
you're clear?
So
And
what we have, if we have like mixed parentheses like curly and everything.
you can do that with them also. You have to find out an approach for that also. In case if you have multiple characters, you can quickly see what kind of strings you do have. You can change your logic accordingly. Arush, is that clear?
Yes, sir. Yes.
Chalo. Let's write that now. So what are we going to do here? Let's just make a new program, solution1.py. ओके तो अब आप solution1.py में करने क्या वाले हैं? तो आपके पास एक स्टैक है, ठीक है? आपके पास जब भी ओपनिंग ब्रैकेट आएगा, आपको क्या करना है? उसे पुश करना है. एंड जब भी आपके पास कोई क्लोजिंग ब्रैकेट आएगा, तो आपको स्टैक के ऊपर पॉप करना है ताकि आपका ओपनिंग पैरेंथेसिस वापस निकल आए, ठीक है? और आपका स्टैक एम्प्टी हो जाए या फिर स्टैक के एलिमेंट्स जो भी हैं कम हो जाए अकॉर्डिंगली. एंड वी हैव टू इंश्योर वन मोर थिंग कि जब भी आप ये पुश एंड पॉप ऑपरेशन परफॉर्म कर रहे हो, ठीक है? सो अगर आपका स्टैक, अगर आपकी लेंथ ऑफ स्ट्रिंग कंप्लीट हो गई है, ओके, एंड इज बैलेंस्ड, अगर आपका फॉल्स आ रहा है तो दैट मीन्स अनबैलेंस स्ट्रिंग है. अगर इस बैलेंस ट्रू आ रहा है और लेंथ खत्म हो गई है, पूरी स्ट्रिंग की आइटरेशन हो चुका है, ठीक है, स्टैक भी एम्प्टी है, तो दैट मीन्स इट्स अ बैलेंस्ड स्ट्रिंग. सो बोथ वेज यू कैन क्विकली चेक बैक. ओके, तो हम स्टार्ट करते हैं इसको. लेट्स से आई एम गोइंग टू टेक अ स्टैक, ठीक है? आप एक स्टैक क्रिएट कर लो. Palak, are you writing the code with us? You have to do that with us. This is the solution. I'll be explaining it step by step, and then you'll understand what was happening. Okay, I'll just mark it over here also. Suppose we do have two strings. One is the balance.
Excuse me,
Yes.
how to come out of the Python editor?
You can come out using Control X. अच्छा, EXIT and double and round parenthesis. EXIT round parenthesis.
Okay, EX. Oh, all right.
Okay, suppose. So we do have, this is a balanced string, let's say, and this is an unbalanced string. These are the two strings which we are going to test. Okay, and let's say like that. So, ठीक है, Palak, now you have to understand what are we trying to do. ठीक है? Now, what I'm saying is my voice audible, Palak?
Yeah.
ठीक है. So now what you have to do, solution approach हमारा ये कहता है कि आपको एक स्टैक लेना है, एक एम्प्टी स्टैक लेना है, ठीक है? आप मान लो कि ये जो अंदर वैल्यूज हैं, ठीक है, these are just blank values. ओके, मतलब नहीं है, कोई वैल्यू नहीं है, ठीक है, खाली है. ओके, अभी कोई नहीं है, एम्प्टी स्टैक है, इट्स जस्ट एन एम्प्टी स्टैक. नाउ व्हाट एम आई गोइंग टू डू? लेट्स से हमारे पास जैसे फर्स्ट एलिमेंट हमने इनकाउंटर किया, ठीक है, हम कह रहे हैं कि अगर ये ओपनिंग पैरेंथेसिस है, ठीक है, तो वी आर गोइंग टू पुश दिस ओपनिंग पैरेंथेसिस, इसको ना हम स्टैक के ऊपर पुश कर देंगे, ठीक है, वी आर गोइंग टू पुश इट हियर. नेक्स्ट पैरेंथेसिस हमने देखा, नेक्स्ट पैरेंथेसिस अगर हमारा क्लोजिंग पैरेंथेसिस है, ठीक है, if it is a closing parenthesis, तो हम पॉप ऑपरेशन परफॉर्म करेंगे, which means we are going to pop out of the stack. पॉप आउट करेंगे तो फिर दोबारा से एम्प्टी हो जाएगा और स्ट्रिंग बैलेंस हो जाएगी. यानी अगर आपका स्टैक एम्प्टी है और आपके दोनों स्ट्रिंग्स ओपनिंग ब्रैकेट और क्लोजिंग ब्रैकेट निकल करके आ गए हैं, तो दैट मीन्स इट्स अ बैलेंस ब्रैकेट, ठीक है ना? ओपनिंग भी था और क्लोजिंग भी था. इज दैट क्लियर? ये क्लियर है?
Yeah.
ठीक है, नाउ लेट्स सी. अब बढ़ते हैं हम इसको आगे. लेट्स क्विकली हैव अ लुक. ओके, आई जस्ट नीड टू क्लियर इट अगेन. ठीक है, क्लियर ही करना पड़ेगा. चलो बताते जाते हैं साथ साथ में, ठीक है? तो वी क्रिएटेड अ स्टैक. अब हमें क्या करना है, एक हम यहाँ पे एक वेरिएबल बना रहे हैं, इज बैलेंस्ड इज इक्वल टू ट्रू, लेट्स से. ओके, इस बैलेंस्ड क्या करेगा, हम बाय डिफॉल्ट स्टार्टिंग में कह रहे हैं कि मान लो जो हमारा स्टैक है वो बैलेंस्ड है, या जो हमारी स्ट्रिंग है वो बैलेंस्ड है, रफली वी आर सेइंग। अब अगर कोई अनवांटेड पैरेंथेसिस हमें इनकाउंटर होगा तब हम इस बैलेंस की वैल्यू को फॉल्स कर देंगे, ठीक है। विल चेक दैट कंडीशन। उसके बाद लेट्स से आई जस्ट राइट द स्टेटमेंट्स ओवर हियर also. Let's say create an empty stack, okay, followed by initialize string as balanced, okay. By default we are saying that the string is a balanced string, okay. Next, I is equal to 0. So this is something iterator to iterate over each parenthesis in string. जो भी आपकी string होगी उसके अंदर by default मतलब हम iterate करेंगे, ठीक है। दो strings भी बना लेते हैं, let's say before writing the code आप लोगों को ताकि clear हो जाए। Let's say मैं कहता हूँ एक B string है, so B string is something which is a balanced string. Let's say मेरे पास एक opening bracket था, मेरे पास एक closing bracket था, ठीक है। opening था, sorry क्लोजिंग था, फिर ओपनिंग था, लाइक दैट, ओके। नेक्स्ट मैं एक अनबैलेंस स्ट्रिंग बना लेता हूँ, यूज स्ट्रिंग, एंड दिस यूज स्ट्रिंग इज गोइंग टू बी, लेट्स से आई हैव अ क्लोजिंग पैरेंथेसिस, सेकंड क्लोजिंग पैरेंथेसिस, थर्ड पैरेंथेसिस एंड फोर्थ पैरेंथेसिस, ठीक है। तो वी गॉट लाइक दीज टू स्ट्रिंग्स मेड, ठीक है। अब आप एक काम भी कर सकते हो कि इसको मैं ना इसकी स्पेसेस को क्लियर कर देता हूँ, बिकॉज ठीक है। अब आप देखोगे तो अब आपको यहाँ से बैलेंस और अनबैलेंस्ड हमें आइडेंटिफाई करना है, ठीक है। दिस इज अ सैम्पल बैलेंस्ड स्ट्रिंग, एंड दिस इज अ सैम्पल अनबैलेंस्ड स्ट्रिंग, ओके। पलक, इज दैट क्लियर? अभी बाय डिफॉल्ट आपको क्लियर है कि ऊपर वाली बैलेंस्ड है, नीचे वाली अनबैलेंस्ड है, क्योंकि हम विजुअली अपनी आंखों से देख पा रहे हैं कि बैलेंस्ड और अनबैलेंस्ड है, ठीक है। बैलेंस का मतलब इक्विवेलेंट नंबर ऑफ ओपनिंग एंड क्लोजिंग पैरेंथेसिस है, अनबैलेंस का मतलब अनइक्वल नंबर ऑफ ओपनिंग एंड क्लोजिंग पैरेंथेसिस है, ठीक है। हमें प्रोग्रामेटिकली स्टैक को यूज करके आइडेंटिफाई करना है कि हमारी बी स्ट्रिंग एक्चुअली में बैलेंस है या नहीं और यू स्ट्रिंग एक्चुअली में अनबैलेंस्ड है या नहीं, ये हमारा ऑब्जेक्टिव है। This is clear to you? Guys, is that clear?
Yes, sir.
Yes, sir.
Now, let's get to the next step. ठीक है, अब हमें क्या करना है, तो हमने अपने वेरिएबल्स इनिशियलाइज कर लिए, हमने अपनी स्ट्रिंग पैरेंथेसिस इनिशियलाइज कर ली। Now we are going to iterate over each element within the string, ठीक है। जो हमारी B string है या जो भी हमारी U string है, इसको हम आइटरेट करेंगे, ठीक है। तो फर्स्ट अटेम्प्ट पे मान लो मैं एक काम करता हूँ, बी स्ट्रिंग और यू स्ट्रिंग को ना मैं एक्चुअली स्ट्रिंग ही ले लेता हूँ, या चलो अच्छा कोई नहीं, नीचे दोनों मेथड्स तरीके से पास कर देंगे, वैसे ही बनाऊंगा, ठीक है। अब हमें करना क्या है, नाउ लेट्स से लेट अस डिफाइन अ मेथड, ठीक है। विल डिफाइन अ मेथड, लेट्स से check balance. I'm defining a method check balance and I'm going to provide a string here, okay. String इसका parameter होगा, and I believe you all remember how we have created methods previously in Python fundamental classes. सभी को clear है ना कि हम कैसे बनाते हैं, method कैसे बनाते हैं? I believe this is clear to everyone.
Yes, sir.
Now let's make a while loop now, ठीक है। Now what are we doing? We are making a while loop, and within this while loop, what are you going to do? You are going to iterate over each element within the string, okay? So जैसे आपकी B string है या आपकी U string है, आप उसकी हर एलिमेंट को आइटरेट करोगे, जब तक आपका आइटरेटर लास्ट एलिमेंट तक नहीं पहुंच चुका है तब तक ये लूप रन होगा, ठीक है। तो आई हैव यूज्ड माय आइटरेटर एंड आई हैव डिफाइंड till the time my iterator is less than the length of my string, whatever string we are giving in, okay. This is the first condition to match, okay. And second condition to match is if is balanced is equal to true. अगर लास्ट में is balanced अगर true है तो भी हम अंदर जा करके चेक करेंगे, ठीक है, एनी ऑफ द स्पेसिफिक कंडीशंस की स्टैक एम्प्टी तो नहीं है, या स्टैक में कोई अनवांटेड मटेरियल तो नहीं रह गया, मतलब अनवांटेड पैरेंथेसिस तो नहीं रह गई है, काइंड ऑफ दैट. ओके, सो वी आर डूइंग दिस चेक आल्सो इफ इज बैलेंस्ड. ठीक है, दो कंडीशंस हो गई अब हमारे पास, यानी जब तक हमारा आइट्रेटर पूरे लास्ट एलिमेंट तक नहीं पहुंच गया है, ठीक है, और इसी के साथ में हमारी जो स्ट्रिंग है वो बैलेंस है, अब तक जितने नंबर ऑफ पैरेंथेसिस हम एक्सप्लोर कर चुके हैं तब तक हम लूप को रन करते रहेंगे. अगर एक बार भी इस बैलेंस अगर आ गया हमारे पास तो कंडीशन मैच नहीं होगी एंड वी विल कम आउट ऑफ दैट लूप. ठीक है, जैसे ही हमारा स्टैक एम्प्टी हो गया एंड इफ वी गॉट टू ऑब्जर्व कि मतलब हमारे पास कोई भी ओपनिंग पैरेंथेसिस है, ठीक है, या क्लोजिंग पैरेंथेसिस इंडिविजुअल लेफ्ट आउट है, तो दैट मीन्स it's an unbalanced string. Now, so what are you going to do? Now, once we have got this, now we are going to read the first character from the string. तो जो भी हमारी string हमें receive होगी उसके हम first character को read करेंगे, और first character को read करने के बाद हम मान लो उसको parenthesis के अंदर store कर देंगे. Here parent का मतलब है parenthesis. Okay, so what I'll say is read parenthesis at index. So whatever iterator index जो भी हमारा होगा उस पैरेंथेसिस को हम रीड करेंगे और पैरेंट नाम के एक वेरिएबल में हम स्टोर कर देंगे, मान लो. ठीक है, अब हम चेक करेंगे क्योंकि हमें दो ऑपरेशन करने हैं कि अगर हमारे पास ओपनिंग ब्रैकेट है तो हमें पुश करना है, अगर क्लोजिंग ब्रैकेट है तो स्टैक के अंदर से हमें पॉप करना है, अगर स्टैक के अंदर कोई एलिमेंट है. अगर एलिमेंट नहीं है तो हमें ये चेक करना है कि हमें इस बैलेंस को हमें फॉल्स कर देना है कि नहीं भैया बैलेंस नहीं है ये स्ट्रिंग, अगर आपका स्टैक एम्प्टी है तो. ठीक है, so we are going to check if parent, okay, is equal to, we are going to match it if it is an opening bracket. ठीक है, अगर जो हमारा parenthesis आया है वो कोई opening bracket है तो we are going to append it or we are going to push on to the stack. Okay, तो मैंने stack बनाया था, stack dot append. Okay, and what am I going to append? I'm going to append parent. ठीक है, जो भी हमारा वेरिएबल है हम उसे अपेंड कर देंगे. सेकेंडली एल्स इफ, अगर मान लो ये जो आपका पैरेंथेसिस है वो क्लोजिंग पैरेंथेसिस है, तब क्या करोगे? इफ इट इज अ क्लोजिंग पैरेंथेसिस तो क्लोजिंग पैरेंथेसिस में हम पॉप कर देंगे. ठीक है, पॉप करोगे, पॉप करने से क्या होगा कि वो मैच हो जाएगा, जो भी आपका उसका इक्विवेलेंट जो एग्जिस्टिंग ओपनिंग ब्रेसेस है उसके साथ में वो कंटेंट मैच हो जाएगा. ठीक है, तो अब हमने यहाँ पे चेक किया इफ स्टैक, अगर हमारा स्टैक एम्प्टी नहीं है तो विच मीन्स इफ वी डू हैव सम एलिमेंट्स विद इन द स्टैक वी आर गोइंग टू परफॉर्म पॉप ऑपरेशन ऑन द स्टैक. ओके, else we are going to set the value of is balanced, is underscore balanced is equal to false. ठीक है, is that clear? Till here? So if there is an opening bracket, we are going to append it onto the stack. If there is a closing bracket, we are going to pop it out of the stack. So if there is any character or any parenthesis left in the stack, okay, it becomes an unbalanced stack. In case if the stack is empty, all the length has been done, we are at the last one, the last character matching, so again his balance is going to become false. Okay, now what are we going to do? Now we are going to come out of the loop and we are going to write, we are going to increment the counter by 1. Okay, so let's increment the counter is equal to I is equal to I plus 1. We are going to increment the counter, or I is equal to plus equal to 1, that also you can call. ठीक है, दोनों ही ऑप्शंस आप यूज कर सकते हैं. सो दिस वी आर डूइंग इन आफ्टर द इफ एल्स स्टेटमेंट हैज कंप्लीटेड. ठीक है, जैसे इफ एल्स कंप्लीट हो गया, अब हम क्या चेक करेंगे? जब सारे आइटरेशंस हो चुके हैं, ठीक है, एंड स्टिल इफ देयर इज एनी एग्जिस्टिंग पैरेंथेसिस विद इन द स्टैक, तो अगेन हमारा इज अंडरस्कोर बैलेंस्ड हो जाएगा फॉल्स. ठीक है, यानी अगर कोई भी पैरेंथेसिस रह गया हमारे स्टैक के अंदर, so that means it is an unbalanced stack. Okay. So finally, what we are going to do, we are going to get it printed. Okay. So I'm going to call this print function, and I'm going to call my method. My method is check balance. Okay. Within this check balance, first I'm going to pass b underscore string, which is the balance string. And second I want to check is check balance. And this is going to be our unbalanced string. Okay. Is that clear? So just quickly walk through the code. So we got two strings, one B string, one U string. We have to check which one is true and which one is false. Okay. We got into this method. We created a method check balance. We took a string. We initialized an empty stack. We initialized is balance equal to true, iterator as 0. Then we loop through each and every element or parenthesis within the string. If the parenthesis is an opening parenthesis, we pushed it onto the stack. If the parenthesis was a closing parenthesis, we popped out from the stack. If the stack was not empty, if the stack was empty, then we have set is balance is equal to false. Okay. We iterated over the next element, and finally, once we are done iterating all the parentheses within the string, and still if the stack is not empty, that means again it is an unbalanced string. So if it's false, we are going to get, if b string, which is our balanced string, we need to get true in the first answer and false for the second answer. Okay, let's save it. Control O. My solution1.py of 22 lines has been written. I'm going to close it, and I am going to run it Python solution1.py. Okay. So एक यहाँ पे मैंने क्या इनवैलिड सिंटेक्स कहीं पे कुछ कर दिया, एक मिनट चेक कर लेते हैं. Check balance use string print function. अच्छा 2.7 है ना ये. So okay, we can push it like a space. Nano. Let's go to solution. The Python version on this instance is a previous one. ठीक है. तो आपको क्या करना होता है, आप डायरेक्टली चेक बैलेंस को प्रिंट कर लो. Okay, we're getting none. I think that's not initialized. एक बार check कर लेते हैं उसको. Nano solution1.py. ठीक है, ये हमारी b string initialized है, ये हमारी u string initialized है. ठीक है, b underscore string, u underscore string. We defined check balance, b string and u string. Balance string and u string extend. Okay, what I'll do is, the method name is correct, right? Check balance, a string. Okay. I'll check with this. Okay, I'm just checking with that. Python solution1.py. Why am I getting none, man? Okay, एक बॉयलर प्लेट कोड डालते हैं. The solution is correct. We can quickly test it on any of the latest version. If init equal to main, if underscore init. Actually, not 2.7 version. Next time I'll upgrade the version of this ताकि आपकी 3.9 वर्जन चल सके. Put here Python solution 1.py. अच्छा indentation error. Okay, sorry. Nano solution.py, that's fine. ठीक है, define check balance string. एक सेकंड ना. I'll just quickly check the boilerplate code now. If underscore name, अच्छा underscore main है. ठीक है. ठीक है. I'll get back here. ठीक है. I'll just go to name solution1.py. Get back to the bottom. If name is equal to main, Python solution1.py. हमने डिफाइन कर दिया. चेक बैलेंस प्रॉपर्ली डिफाइंड है. ठीक है. b underscore string and the second one is u underscore string. I'm just checking that with this एक बार. What's happened? एक second ना. I'll just quickly run it on a अरे ओके एक सेकंड. मेन नहीं बनाया उसने. अंडरस्कोर मेन. ठीक है, Python solution1.py, your name solution1.py, and it is saying b string and u string को वो नहीं रीड कर पा रहा है. अच्छा, एक सेकेंड ना. So we have not returned the statements. रिटर्न भी तो करना पड़ेगा हमें is balanced. ठीक है. So अब यहाँ पे आप एक काम करो, just you have to return it. Return is underscore balanced. ठीक है. हमने रिटर्न स्टेटमेंट नहीं किया है इसलिए वो नल दिखा रहा है. ठीक है. We have to return the statement also. So now we have returned the statement and now we are going to run Python solution1.py. So now you can see that अभी यहाँ पे मेरे पास आ रहा है false आ रहे हैं दोनों, जबकि दोनों false क्यों आ रहे हैं? कहीं पे कुछ गलत मैच कर दिया क्या? एक सेकेंड ना, दोबारा रिव्यू कर लेते हैं. 1 2 3 4. ठीक है, इसको भी रखते हैं, इसको भी क्लोज करते हैं. 1 2 3 4. ये हमारे पास स्टैक अपेंड ऑपरेशन है. हमने स्टैक को पॉप कर दिया, बैलेंस हमने इसको ट्रू कर दिया, इंक्रीमेंट कर दिया ऑपरेटर. अगर हमारे स्टैक में कुछ वैल्यू है, इस बैलेंस को हमने फॉल्स कर दिया और फाइनली हमने रिटर्न कर दिया इस बैलेंस को. ठीक है. Okay, let's run Python solution1.py. Now you can see that. So we are getting the first one as true and the second one as false. ठीक है. So अब ये properly एक बार मैं आपको कोड वॉक थ्रू कर देता हूँ. तो अब क्या है कि हमारी ये बैलेंस स्ट्रिंग है, ओपनिंग ब्रेसेस, क्लोजिंग ब्रेसेस, ओपनिंग ब्रेसेस, क्लोजिंग ब्रेसेस. So this becomes a balance string. वो पहले वाली अनबैलेंस मैंने बना दी थी क्योंकि उसमें भी क्या है कि अगर आपकी पैरेंथेसिस गलत तरीके से प्रोग्राम में यूज हो रही है, मतलब मान लो किसी ने क्लोजिंग ब्रैकेट पहले लगा दिया और ओपनिंग ब्रैकेट बाद में लगाया, तो नेचुरली वो प्रोग्राम गलत हो जाएगा, कंबाइन नहीं होगा, है ना. मतलब सो वी हैव टू इंश्योर दैट कि जितने नंबर ऑफ ओपनिंग प्रॉपर पैरामीटर्स हैं उतने ही नंबर ऑफ क्लोजिंग पैरामीटर्स भी हमारे पास होने चाहिए. जैसे मान लो this is a proper closing parenthesis. ठीक है. और यहाँ पे भी 4 बराबर हैं, let's say closing opening closing opening. ठीक है. So this is an unbalanced string. सेव करते हैं, कंट्रोल ओ करके सेव किया, कंट्रोल एक्स किया, पाइथन से रन किया, Python solution1.py. So now you can see that the first one is true, second one is false. Okay. Vice versa हम इसको चेंज कर लेते हैं. जैसे मान लो मैं इसको इस बार एक प्रॉपर बैलेंस स्ट्रिंग बनाता हूँ. मतलब मैंने कहा कि आई एम जस्ट राइटिंग सम डिव कोड. 3 बार ब्रैकेट आए, 2 बार क्लोजिंग आए. ठीक है. फिर 1 बार ओपनिंग, 1 बार क्लोजिंग, फिर फाइनल क्लोजिंग. सो दिस इज अ बैलेंस्ड वन प्रॉपर. और ऊपर वाले में कुछ ऐसे डाल देते हैं. ठीक है. ऐसा कुछ एक डाल दिया. ऊपर वाली अनबैलेंस्ड है अब मेरी. ठीक है. सो मैंने इसको कंट्रोल ओ किया, सेव किया, कंट्रोल एक्स किया, एंड आई हैव गॉन टू Python solutions.py. रन किया इसको, तो फर्स्ट वन बिकम्स फॉल्स, सेकंड वन बिकम्स ट्रू. इज दैट क्लियर? जस्ट गिव मी अ confirmation if this concept is clear to you, that how do we actually make use of stack in order to solve a problem of identifying balanced parentheses in a source code or in a string. Give me a confirmation. This is clear to all of you. Palak, now is it clear?
No, I will go through it after the lecture.
Okay. Use this lab. Have you registered on the website where you can access this lab? Have you got that clear?
Yeah.
ठीक है. So you have to get this lab. You have to register on this. I'm just sharing the link with you. Okay, on chat. You have to register for programming languages here. Once you register for programming languages, you have to log into your one-to-one account. Within your one-to-one account, you're going to have your data structures using Python self-learning program here. And in case if you guys don't have your ID and passwords, so what you can quickly do is you can go to your Trello cards, and within the card which I have created on your this one, what do you say, on your board under interns group 8, let's say here. So at the very top, you have your Hackveda one-to-one details available. Okay. So in case if you don't have that access to the account, you can quickly log into your Hackveda one-to-one account. And from there, you will be able to access your course. Once you access the course, you have to get into this one, data structures using Python. You have to click on it. Once you go to data structures using Python, currently we have 2 labs created. 2 labs हमने यहाँ पे create किए हैं. आपका जो first lab है वो introduction to Python है, जिसमें basics of Python like numbers and all, setup and everything, वो वाला lab है, वो भी आप practice कर सकते हैं. वैसे बहुत simple lab है, already आप लोग जानते हैं. And second lab जो है आपका, वो है stacks. Okay, so you can quickly make use of this solution approach. In case if there is no clarity or anything, I do have recorded a video as well here, just to give you a quick concept support. And this video which we have recorded of the main session, that will also be available on your card. Okay, so guys, I believe you understood the practical utility of stack in cases. So we will be exploring a lot more algorithms on using stack in order to reach out to the solution. For now, I believe this problem statement, the problem 1 of checking the balance string, is clear to both of you, Jaideep and Arush.
Yes, sir.
Clear? Okay, sure. That's all for the day. Let's catch up in the next session.